systematic error is something in your equipment or your procedure or your methods or your assumptions that lead to your values being too large or too small. So any result calculated from that value will have an error, and it will be further from the true value of the result. Okay, so normally when you have some items and you want to get a value, this is an electronic balance, so it's getting mass. You put the items on and you would get a final value. So you can see it individually, they might have slightly different masses. I've got a 204.1, I've got a 102.1, and the last one is 20.5. And then the electronic balance adds it all up, and you've got 326.6. Now individually, they might add together to 326.7, and that's because when they were measured individually, they each had an individual uncertainty, and it's totally normal for small quantities when you do a calculation to be within a certain accepted range of an individual measurement. That's a random error or a measurement error limitation, so that's totally normal, okay? So if you take these off, what sometimes people will do, especially when they have very fine or very small particles or powders or something like that, they'll often have a pan that they use, right? Now this pan by itself has a mass of 192.1 or 192.0. It's sort of varying a little bit. So when you put that on with the masses, the total mass is larger. So you could do that and you could subtract off the mass of the pan itself, which would be fine. But what often equipment will have is they'll have a 0 or a tare button that when you press it, will subtract off for you the mass of the container. And that means that when you put the objects in, it'll get the same value as before, as if there was no pan at all. And you have the advantage of being able to have something containing that loose powder or something like that, okay? But what can happen is somebody will leave and the next person will come and they won't necessarily realize that it's been mistared. They'll be in a rush or whatever. So they put their objects on, and some things are not as obvious that they've been miscalibrated, right? And they get a value and they think, oh, fine, it's good. This is an electronic. Oh, look, even digital. I trust that even more, right? And they're like, oh, that's my value. I'm going to write it down. That has a systematic error to it. So that means that any value calculated using this value will have a systematic error and will be either too large or too small from its true value, okay? So what you should do is, if you have the option of calibrating a device, you would calibrate it or tare it before you start, so set it to a certain conditions, and then it's measuring relative to that. This device is keeping figures to one place after the decimal, so it's estimating its uncertainty is probably to that last decimal place. If you have a manual for this device, you might be able to calculate what a total uncertainty would be. For this device here, we normally include an uncertainty of about 0.1 grams for every 100 grams. So because this is close to 300 grams, I would give this an uncertainty of 326.6 or 5. You can see it's actually somewhere between 5 and 6 for the last digit, but it seems to be staying on the 6 for longer, so I would say 326.6 plus or minus 0.3. So 0.1 for every roughly 100 grams. Okay, thank you.